Lesson 6-1. I can solve a system of equations by graphing is our learning target. And then our essential question is, how do you solve a system of equations? By graphing. So we have already worked with 3 different types of systems. So remember, some systems have one solution. That happens when the lines are intersecting. They intersect because they have different slopes. And here's a graph that's an example of intersecting lines. We also found that a second case, there were no solutions. That happened when the lines were parallel. And parallel lines have the same slopes but different y-intercepts. And parallel lines on a graph look like that. Then the third situation that can occur is when your equations actually represent the exact same line. So those are called identical lines, and they have infinitely many solutions because they have the same slope and the same y-intercept. And you don't always recognize that right away because they're usually written in different forms. So you usually can't tell until they're written in the same form. I guess this is not grouped anymore. So anyway, on the graph, it looks like there's only one line because they are exactly the same. So they have infinitely many solutions. They intersect at every point on the graph, every single point on the line. So it's an infinite number. So there can be one point of intersection. There can be no points of intersection when they're parallel, or an infinite number when the lines are identical. So today we're working with graphing lines. So just to review, that when equations are written in slope-intercept form, you graph the y-intercept first. And the y-intercept goes on the y-axis. Then you use your slope to find more points on the line. So slope-intercept form, the letter M is the slope and the letter B is the y-intercept. Graph the y-intercept first, use the slope to find more points on the line. And you might need quite a few more because we're looking to see where lines intersect, and they don't always intersect if you're only graphing 2 or 3 points on the lines. All right, so the first one has an intercept -1, and then the slope is 1/2. Remember, slope is rise over run. So rise over run, if it's 1/2, I rise 1, run 2. Rise 1 means I'm going up 1. Run 2 means I'm going over 2 to the right. Now notice I'm just going to continue my line in both directions for a while because I'm not sure where it's going to intersect. So I'm just going to fill pretty much all of my coordinate plane. The second one, y-intercept -3, slope 3/2. So that means rise over run, rise 3, run 2. And here's where they cross. So these lines are intersecting. There's one solution, and that solution is the ordered pair. Let's see, I need an x-coordinate first. So the x-coordinate is 2, and the y-coordinate is 0. So 2, 0. So this point right here is 2, 0. Next example, start at -1. This one has a slope of 1 over 1. So rise 1, run 1 to the right, put a bunch of points on in both directions because I don't know where they're going to cross. And then the other line starts at 5, and it has a slope of -1 over 1. So that means that I'm going to go down 1 over 1 to the right, and there's where they cross. So They are intersecting with one solution, and the solution this time is the ordered pair. I would go to the right 3 and then up 2. So 3, 2. Next one, 3 is my intercept. My slope is -1/2, so -1 over 2. Down 1 over 2 to the right. The second line starts at -2. The slope again is -1/2. So down 1 over 2 to the right. These lines, because they have the same slope, are parallel. Parallel lines do not cross, so there's no solution. Next one, start at 3. Slope is -1, so -1, down 1, over 1 to the right. Then -6 is my second intercept. And remember, if it doesn't look like a fraction, put a 1 under it. So my slope, I rise 2, run 1. Here's where they cross. So intersecting lines, one solution, 3, 0. Next one, start at 5. My slope is -3 over 1, so down 3 over 1. Draw my line. And then my second one, notice the y is not by itself. So I circle the y, and I would need to subtract 3x on both sides to cancel it out. So I have y equals -3x plus 5 when I put it in slope-intercept form. So I start at +5, and my slope is down 3 over 1. So take a look at that. It's the exact same line. So these are identical. And there's an infinite number of solutions then, because they intersect at every point on the line, and the line goes on forever. All right. Next one, start at 1. Slope -2/3. So down 2 over 3. Reverse it. And the second one starts at +4. And it goes up 1 over 3. And I need to reverse it to see where they cross this time. Right there. So intersecting, one solution, and that ordered pair is to the left 3, so -3 for the x coordinate, and then up 3, so -3, 3. And that was our last example. So hopefully you understand how to graph the lines and solve the system.